So in last few sessions, I think I had tried my level best to explain to you the technique with which the discrete Fourier transform is computed in a fast manner. Therefore, it is called as fast Fourier transform algorithms, and the same can be achieved by two different ways of looking at DFT as regard to design of the algorithm for finding the transform in a fast manner is concerned. If so ever some gaps in understanding have remained, I am very much sure that those would be clear beyond doubt in the experiment which we are going to conduct for group learning tomorrow and day after, or it will be starting today. Now, as regards to discrete Fourier transform, since it was introduced last semester itself, we did not go through the detailed properties. Also, we just mentioned the inverse discrete Fourier transform. Now, let us try to revisit both things in detailed manner. So, inverse DFT, that from xn we go for xk. So, based on that formula, how can we derive the formula for inverse DFT? So, the task now which will develop, it will not be discussion as such. I will expect everybody to proceed along with me. Means I will write one step, I will hint for the second step, I allow you to write completed step, then I will write the second step, and then we shall proceed simultaneously. So the agenda for today's discussion is deriving or developing, we can say, not deriving, developing the formula for inverse discrete Fourier transform, which we know. Inverse DFT is found out. Means we already know what is xk. For an n-point DFT, we know that xk, where k varies from 0 to n minus 1, is equal to summation small n equal to 0 to n minus 1 xn wn raised to k. Right? Now, we want to develop, means from knowing capital N values of x small n, that is small x bracket 0 to small x bracket capital N minus 1. From these capital N values, we are able to find out capital X bracket small 0 to capital X bracket small capital N minus 1. That is the DFT. So from n points of sequence, we can find n points of DFT. Then I will give some hint that DFT is an invertible transformation. Means if you can find from sequence points the transform points, then from transform points also you can find the sequence points. From transform points also you can find the sequence. So the formula for transform points is given like this. Formula for transform points is given like this. Now we want, how will you develop the formula for sequence points from transform points? Means from x0 to x capital N minus 1, from these, once these are known, this formula will allow us to find out now the question is, if this is known, since it is an invertible transformation, this has to be found out, this must be found out, this can be found out. Question now is, how you will develop a formula which will give me value of x0 from all these values, value of x1 from all these values. How? How you will get that? So let us try to develop it by a common sense method called as brute force method, and also we can develop it by using a matrix method. By both methods we can develop. I would like that everybody must get a feel of what we are doing. Otherwise, when I am very much stressing on these issues, because otherwise there exists a large population who has learnt and passed the DSP course without knowing what the field means. There exists in this world a large population which has not understood what capital WN is, but still they have passed. So when we develop the formula, let us feel that the formula means we are deliberately taking this as a classwork in group learning and self-developing, because when you look at the formula, everybody of us should feel that yes, I am the developer of this formula. It should look like to be your formula for you. So from that point of view, we are proceeding. So now, xk is, there are such, how many equations?
N equation.
Capital N equations. x0 to xn minus 1. x0 to xn minus 1. There are capital N equations for k from 0 to n minus 1. So now, from this, how we will proceed further? How we will proceed? How we will? We want. See, in this xk, if I get a single xk, there, how many terms are there in this summation? N terms, capital N terms. Or again, just for the sake of some kind of definedness rather than abstractness, for no other purpose, for some kind of definedness rather than abstractness, let us derive it for n equal to 8. So that while hoping that you are giving proper attention to what I am talking, and if you are giving proper attention to what I am talking, then during the talk, whenever I have to utter the words x0 to x capital N minus 1, that provides an hearing and understanding impediment whenever I say x bracket capital N minus 1. So these are some black spots in a proper understanding flow, provided that otherwise the flow is proper. Are you getting me? So therefore we avoid abstract thing like capital N and take an actual thing like 8 for time. So we can say n equal to 0 to 7. Right? So the signal points are x equal to 0 to x equal to 7, and transform points are kept. small x0 to small x7, capital X0 to capital X7. Now, there will be such 8 equations, capital X0 to capital X7. So, in this single equation, what I am having, there are 8 terms. There are 8 terms which are being summed up. Means small x0, small x1, small x2, each multiplied by 8. You are developing some new formula. So, in this single, so let us say x, for any value of k, one xk is given by weighted sum of 8 signal points, sequence points. One transform, I again repeat, one transform point is weighted sum of 8 sequence points. One transform point. We have not started group learning. Group learning will be starting in the afternoon. So one transform point is weighted sum of 8 sequence points. Then if we look at single expression, then it is not invertible, because from single transform points I come to know it's a sum of multiple terms, and sum is a non-invertible process. Sum is a non-invertible process because I do not get the individuality. Therefore now, in what way, means what I again repeat, every I have 8 sequence points. From 8 sequence points, I define 8 transform points such that each transform point is a weighted sum of 8 sequence points, and the weights vary depending upon which transform point I am computing. I have 8 sequence points. I have an 8-point DFT. 8-point DFT provides me 8 transform points. Each transform point is a weighted sum of all 8 sequence points. Only thing is that the weights vary depending upon the index of the transform point. Right? Then, how I can go for inverse transform? How I can and I should go for finding inverse transform? Capital X0 is a weighted sum of small x0 to small x. Capital X1 is again a weighted sum of small x0 to small x. Likewise up to capital X7. And now, so since if small terms are known, these sequence points are known, since we have a formula for transform points, from sequence we can find transform. Now, if all transform points are known, how you will retrieve back the sequence points? So I have got one expression of summation of 8 terms for one transform points, and I have got such 8 transform points. These 8 equations I have. From these 8 equations, I want the inverse equation, so that once 8 transform points are known, from them I should be able to retrieve the sequence points. So how can you do that? What is the approach? Many of those who have learned DSP know the formula, but knowing formula is not enough. So what should the approach? How I will find x0? How I will find x1? Small x0, small x1. How? Got the problem statement clear? For capital X0 there is one equation. For capital X1 there is another equation. For capital X2 there is another equation. For capital X7 there is another equation. Right? So capital X0 is equal to summation n equal to 0 to 7 x n only. Right? Why? Or you can write W in this way. Capital X1, capital X2, capital X3. So from these 8 equations, I find that, let us, I want to find x0, small x0. Let us find small x0. I have done this. Or I can rewrite again. Capital X0 is something into small x0 plus something into small x0. And likewise, and these somethings are nothing but Wn raised to Kn, where this plus this. Kn is this is this, right? This is this, okay. So this is Wn raised to 0. W, not Wn, is W. W raised to 0, W raised to 0, right? And here it will come W raised to 49. 49 is 49 will become what? 1. Right? So it is Kn modulo 8. So now I want everybody to get a feel, to get to the answer, that from these 8 equations, if I am asked to find out small x0, how I will find? Right. So I have got, these are known, these are known, these are known. So there are 8 equations and 8 unknowns. There are 8 equations and 8 unknowns. Right? And that I can solve simultaneously. The hint is again that a simultaneous equation is very simple in that way. But hint is what I should do. I should try to add them by a suitable multiplier such that I will try to add them. I will multiply each equation by some number. I will multiply each equation by some number in such a way that when I add them, so to this I will multiply by something, to this I will multiply by something. So I get multiplied equations and I simply add them. When I add them, I find that the coefficients for x1 are such that they auto cancel each other in this sum. Same is with x2, same with x3. And only for x0 they don't cancel. So I get a non-zero multiplier for x0 and 0 multipliers for others in the added equation. So I can get x0. The next time I multiply the same equation by some other numbers, and like this. Or this I can say as small w00, small w01 up to small w07, and it is small w077, where Wij is equal to W8 raised to Iz. Is it clear? Wij is W8 raised to Iz. Right? Then it becomes matrix. So I see that x0, x7 is a column which is equal to an 8 by 8 matrix W00 till W07, W70 till W77 into x0 till x7. Right? Then if I pre-multiply this matrix equation by a square matrix which is inverse of this, then that inverse into this is equal to this inverse into this, which is I. So I into this is column matrix. So inverse matrix into this is the original sequence. So what is this matrix? So our ability to find this matrix is our ability to find inverse transform. Is our ability to find inverse transform. So proceed for some time and derive or develop the inverse transform for the input pulse.